Hello, this is our final project of Big Data Analytics. Our project name is Discover How to Prevent Bank Card Fraud based on Vesta Corporation dataset. Our group members are Letao, Yucheng, Zhang, Xiaoxi, Liao, and me, Tianyi. Next. The first part is the executive summary. First of all, this project aims to improve card fraud detection accuracy. And our dataset is based on Vesta Corporation dataset from Kaggle. We completed our coding in Jupyter Notebook on AWS. And the whole process can be concluded as data processing, feature engineering, modeling, and model development. The best model for the project is Tianyi LightGBM model, and with a 0.98 accuracy. Next. The second part is business problem. First of all, we want to improve the accuracy of anti-fraud mechanism for bank card products. And second one, we want to optimize the payment service in different sources and devices, such as using your iPhone, using your tablet, or using your desktop or PC or MacBook. And third is to prevent or stop the loss from fraud transactions. And the fourth and the last is to build up advanced overall risk control system for the bank. Next. The third part is dataset description. So let's have an overview of the data. The data is provided by Vesta Corporation, a forerunner in guaranteed e-commerce payment solutions, provided the dataset on Kaggle. And we downloaded all the datasets, and we used two of them. We merged the two datasets together as the final dataset. And the data is broken into two files, identity and transaction, and which are joined by the transaction ID. Next. So here are some key features. The first of all is fraud. The type is Boolean, and it has 0 or 1. So this is our target variable, which we want to predict. And this variable is to identify whether the transaction or not is a fraud. And then we also have the transaction date, transaction amount, and the product type, and some other masked features. Next. The next part, let's welcome Yucheng Zhang.
Okay, thank you, Tianyi. Let me introduce the system design. Next. So first, we will import our libraries, and then we will visualize our data to see the distribution of our features and the fraud. And then we will do feature engineering to merge all the data and to clean unnecessary data to do dimension reduction. And we will apply these features to the different models, and we will optimize the model. Finally, we will use different benchmarks to evaluate the models. Next. So let me introduce the data preprocessing. Okay, so when we use traditional ways to run files on our local terminal, the usage of the CPU is 100%, and the memory is 80%. So the low running speed seriously impacts our project process. The first step we did is uploading the file on AWS. And we process all our work on AWS. Next. We follow the instruction of our lab on our class to successfully connect Jupyter Notebook with AWS, so we can process our data on local terminal. Next. So here we can see the distribution of whether the fraud or not. So next. We have hundreds of features. So our feature processing is also a way to dimension reduction. We remove our single value features. We remove features with more than 90% non-values. And we label non-romantic columns and clear all the infinity value to none and change all missing value to minus 999. And the columns are processing from the 430 to 388. And we split our data 75% of the data into trained data and 25% data into testing data. Okay, next, let's welcome Letao to introducing the model development.
Hi, this is Letao Li, and I'm going to start to introduce this part is modeling and model development. So first of all, we choose some machine learning algorithms like decision tree, random forest, XGBoost, and LightGBM as our benchmark model. As you can see the table, the XGBoost and the LightGBM works best on test AUC score and with only Letao overfitting. And then we apply the two technologies to our basic model. The first one is Tuon. We use grid search to find the best working parameter. And the second one is SMOTE. And we use SMOTE methodology to balance the train and the test data set. So this is the figure that shows we applied the SMOTE oversampling before and after. And this is the feature importance. The left side is the feature importance of the random forest algorithm, and the right side part is the LightGBM's algorithm. As you can see, the details, the feature importance of these two algorithms is very different. And finally, after we applied for the Tuon and the SMOTE to this algorithm, and we finally find out that the tool LightGBM works best with a 0.96 test AUC score and with only Letao overfitting. After tuning with 200 iterations in a randomized search on each model, we got a Letao overfitting, but overall improved LightGBM model with a 0.99 AUC score in the training and 0.96 in the testing, which is quite good. And next, let's welcome Xiaoxi to introduce the rest of the parts.
Thanks, Letao. Since we built several models and do some model developments, here we come to the number 7 parts, results evaluation. Next page. So for the basic model, XGBoost performed best with Letao overfitting and AUC score highest. And for the model developments, Tuon and SMOTE are used to improve the AUC score and reduce overfitting situation. After all, Tuon LightGBM model performed best with the highest test AUC score and the lowest overfitting, which has 98% accuracy rates and 77% precision rates and a 79% record rate. And we upload outputs of these projects to Kaggle and receive the following scores. Next page. And here we come to the conclusion parts. And for our projects, the AUC score and accuracies of the final model is nearly 98%. This is still not much higher than the bad debt rates under the original risk control system. And the predictions output can be used as a reference for the subsequent business anti-fraud max risk control management, but it cannot be used as the main decision basis. And for our experience of the big data analysis, internet finance will have an increasingly large scale of the business in the future, and financial cybercrime may cause enterprise and people to suffer greater capital loss. In the cloud, computing provides a simple way to access server, storage, database, and a wide range of application service over the internet text. So, next page. And here are our reference for the project. We mainly collect all this reference from Kaggle and some data scientists' website. And thank you for your listening and patience. Our presentation is finished.